All right, so we're going to work on evaluating trig functions, and this first objective, really simple. We're just typing these into the calculator. So it's probably an objective you have already mastered, but we'll just practice these real quick. So the first one, cosine of 50 is in degrees, so you need to make sure you are in degree mode. Of course, the reason we're using the calculator is 50 is not on the unit circle. So the approximation of the cosine of 50 is 0.64. We're going to round to 2 decimal places. Part B, the sine of 2 pi over 3, that, of course, you should recognize is in radian mode. If you wanted to, you could convert 2 pi over 3 to degrees, or you can just switch your calculator to radian mode and then type it in. Of course, 2 pi over 3 actually does show up on the unit circle, so we technically could get the exact value for this one. But again, we're just going to concentrate on approximate values in this section. So 0.87 is our answer. Pause real quick and try C and D, and then check to see if you get the right answers. So for letter C, you should have gotten negative 1.73. And for letter D, you should have gotten positive 1.38. If either one of those did not come up as matching as to what I got, check your mode. That is probably what it is. All right, so this next section is going to require a little bit more work. So basically, to solve these problems, we are solving for theta. We're going to go through the instructions here in a second. But we're going to use the calculator. We're going to use our trig sine chart. You want to make sure you copy down the trig sine chart. The one we used plenty of times when we did the unit circle problems. And we're going to use our knowledge of reference angles. So objective number 2 says we are given the trig approximation. So you'll notice in these problems below, they give us a decimal. So that's the opposite, basically, of what we just did. We came up with a decimal in objective number 1. Here we're going to determine all positive, and I'm going to add one little thing to the instructions. We're going to determine all positive values between 0 and 360 for theta. And then we're going to round to the nearest whole number. So in these problems, we're going to have 2 answers, because you may remember there are 2 angles that give us each trig approximation. You should know that from the unit circle, because, for instance, if you take the sine of 30 degrees, we get 1/2. Well, think about what the sine of what angle also gives you 1/2. Of course, that is 150. And the question we need to ask ourselves on all of these problems is, why are they the same? And it comes down ultimately to the reference angle. 30 degrees, if we sketch that real quick, I'm going to erase this in a second. But that's 30 degrees in the first quadrant. And it, of course, has a reference angle of 30, because it's 30 degrees from the x-axis. And then if we sketch 150, which is in quadrant number 2, the terminal side of its angle is also 30 degrees from the x-axis. So since they both have the same distance from the x-axis, you get the same value. All right, so I'm going to erase this, and let's work out problem number 1. So again, we're trying to find theta. So we're going to use inverse trig, which you should have used some of this in geometry. So theta is going to equal the sine inverse of 0.5358. Now, the first couple things I do want you to recognize before we put this in the calculator is sine, of course, refers to the y variable. And also this decimal is a positive decimal. So that tells me my two answers should be in the quadrants where y is positive in. So I should have an answer right here in between 0 and 90. And I should have an answer here in between 90 and 180 degrees. So to get my first answer, calculator usually only comes up with 1, sometimes not even that. But we're going to hit second sine, then type in 0.5358. And we get 32 degrees. So we're going to round to the nearest whole number. So that's one of my answers. And of course, 32 degrees, I'm going to write this underneath, is from quadrant number 1. So if we sketch 32 degrees in quadrant number 1, the thing here is 32 is its own reference angle. So what we need to come up with is we need to come up with what angle in quadrant number 2 has that same reference angle of 32 degrees. So the angle in red we can find pretty easily just by taking 180 and subtracting 32. So the angle in red there should be 148. So 148 should be my other answer. And there's a real simple way to check. Like if we go back to the calculator and we type in the sine of 32, which we know is right because we found that in the calculator, we get 0.5299. Now technically it should equal 0.5358, but we rounded down to get 32 degrees, so it's not going to be exact. But when we type in the sine of 148, it should give us the exact same decimal approximation, so we know that that answer is correct. Let's try two more. Next one is the cosine. So, of course, cosine is the x variable. And we're looking for the quadrants where x is negative. So that means our answers are going to be in quadrant number 2 and quadrant number 3. So to get theta, we're going to use inverse trig. So we're going to hit second cosine and type in negative 0.5663. And we get approximately 124 degrees. So 124 degrees, of course, is in quadrant 2. I'm going to go ahead and sketch it. Just get an idea of what we're looking at here. So this is 124 degrees. So let's determine its reference angle. It's going to be this piece right here, 56 degrees. So we know our other answer is in Q3. So basically what we need to figure out is what angle is going to be 56 degrees from the x-axis in quadrant number 3. So I've sketched an angle that's 56 degrees from the x-axis. So we need to find the entire angle from start to finish. And of course that entire angle is 180 plus 56, which should give us 236 degrees. So 124 and 236, they have the same reference angle, but they're in different quadrants. And then check it. Type in the cosine of 124. Type in the cosine of 236. It's the same decimal approximation, so we know we've got the answers. All right, last one we'll do together, and it is a tangent problem. So tangent, of course, is y divided by x, and that decimal is positive. So I know my answers are going to be in quadrant number 1 and quadrant number 3. So use inverse tangents to get our initial angle. And rounding to the nearest whole number, we get 53 degrees. It's always good news when the first answer is in quadrant 1, because 53 degrees, of course, is its own reference angle. So our other answer is in quadrant 3. So we're, again, trying to find the big angle in quadrant 3 that is the same distance from the x-axis. That is the same reference angle as 53 degrees, but we're just in quadrant 3. And of course, to get that big angle there, we would take 180 and add 53 to it. And then a real quick check, the sine of 53. And the sine of 233. Oh, that's not right. Tangents. We're doing tangents. So the tangent of 53 and the tangent of 233 give us the same decimal. So pause the video real quick, and I want you to try the 3 below, and I'm going to give you the answers here in just a minute. So practice those, pause it, and the answers will come here in about 10 seconds. So here's the answers to the first one, 34 degrees and 326. The answers should be in quadrant 1 and quadrant number 4. So you can see the work there, but 34 and 326. And there's the answers to the last one, the tangent of 40 and the tangent of 220. Both give you a decimal pretty close to 0.832. But of course, tangent is positive in quadrant 1 and quadrant 3.